There we go. So, should you buy stock in Monster? So, here's some data points. What they're giving us is the year and the stock price. Which of the two variables is our explanatory variable?
The year.
The year. And that would make the response variable the stock price, right? Okay, so what we have on the scatter plot are obviously the data points, and they've already gone through and calculated the regression line using technology of some kind, and they drew the regression line right here. Now, are you surprised it doesn't hit every single point? No, it's a best fitting line. It's not a perfect line, it's just a best fitting line. So let's look at this first thing. How would you describe the form of the relationship? Would you say it's linear or would you say it's nonlinear?
Linear.
Linear? Okay. Now it says use the regression line to predict the stock price for 2010. How do we use the line to predict? Plug in what specifically?
The year.
Plug in the year, right, into the equation? Okay. So when we plugged it in the equation, we put in 2010 as our x value, and it came out positive 7.54. And then it says find the residual. Remember, residual means the actual minus the predicted. So we're going to get the actual from the table up here. 2010, it says 368. So my actual is 368 minus what we just found, and we get a negative residual. Number 3, we're going to do the same thing. We're going to predict for 2022. So we're plugging in 2022 into our equation, and we get 4106. And residual, the actual in 2022 is 4501 minus the predicted, what we just found was 3.95. Then what we did is we took our values and we put them in our table that we calculated. And we plotted those residuals right here. And with the residual plot, this 0 line is the prediction line, and these are the residuals that are calculated around that prediction line. So what it's doing is giving us a visual of how far off the points are from the predicted line. What it's actually doing is taking this line right here. If you could pretend that these dots are attached at these distances from the line, if you rotated it down horizontally with those points, it would mimic this shape. We don't want there to be a shape here. We don't want there to be a pattern that's predictable. Otherwise, that means the line is not a good equation. So it says for which points is the actual stock greater than the predicted? Well, actual would mean it's above the predictions. So that would be 2006, 2008, 20, and 22. And which were less than? Well, those are the below the line points, right? Then it says, okay, does the residual plot have a pattern? Yes, it has a pattern. Hopefully you can see that. It is kind of a scooping pattern here. It's doing this, right? It's like a parabolic shape. Well, we don't want that. But so since there is a leftover pattern in the residual plot, the linear model is not appropriate. There's a better equation to fit this data. That's what we're saying here. Okay, so on the be able to, some of this is review for us, especially this part right here. We've talked about this before, about how to put your data in the equation where your explanatory is in list 1, response variables are in list 2, and then use stat calc linear regression to get your values. Now, if you've turned on your stat diagnostics and your stat wizards, you should also get an R value and an R squared value in your output, so make sure those are turned on. But what we haven't discussed so far is how to read it from an output like this one shown. This is really common. It's what you're going to see on testing environments. And you need to be able to look at it and know what the equational line is and a bunch of other stuff. So let me section this off. Now, this part right in here, this stuff we're going to cover when we get to chapter 12. Don't worry about that. Now, this R squared adjusted is not something we ever use, so you can ignore that. These two are in the next simulation, so stay tuned for more details. Now, so what we're really concerned about here are these two. Now, income, or the second line, this is my slope, okay? And the constant is your y-intercept, okay? Sometimes income is not like what it doesn't say. It may say x, it may not. It may be in context like this one. Constant usually says constant, and that constant is your y-intercept. All right, now on residual plots. When is the linear model appropriate? Well, if there's like no pattern at all, it's just a scattered cloud of dots. There's no pattern. Well, when is it not appropriate? It's not appropriate if there is a pattern, and these are the most commonly found patterns, like a parabola facing up, a parabola going down, or it's least common, but it does happen, something like a megaphone or a Christmas tree, something like that. Okay, could go the other direction, but it's something like a triangle. Those are the kind of patterns you're looking for, and you want it to be obvious. It's not one of those magic eyes where you're staring at it looking for something. You're just glancing. If there's no obvious pattern, then you're fine. The linear model is appropriate. So now if we go back to this example down here, this is the one we did in our, if we put these in our calculators, we will get our regression line. All right, so good practice on that. Hopefully your output also has the R and the R squared and all the stuff underneath it, right? We're going to use that on the next one, so don't delete anything, okay? Now it's not giving us a scatter plot, but it gave us the residual plot of this data. All right, if you glance at this, do you see a pattern?
Yeah.
Do you?
Part of it looks like
Don't overthink it.
so no.
No, like it's usually going to be like a parabola, okay? A scoop up, scoop down, or the Christmas tree thing. All right, so it doesn't fit any of that. Like don't try to make a, something out of the clouds here. There's no pattern here. So it says, what does the residual plot indicate about the appropriateness of the linear model? So if there's no pattern, what does that tell us?
Linear model is appropriate.
Linear model is appropriate. So you need to make sure to be like couching everything in context. On your quizzes, I didn't take off on it, but I could have taken off a lot of points for no context on some of the answers. So be careful with that, all right? So we would say, since there is no leftover pattern, in the residual plot, the linear model appropriate for city versus highway fuel economy. By leftover pattern, I mean this. Like on your scatter plot, there's a pattern, right? Looks linear. That's the original pattern. But when we do the residual, it's like, is there still a pattern? That's what I mean by leftover pattern. Okay? We good with that? Okay? Okay, so let's jump over to the next one.